Greetings, building science enthusiasts, and welcome back to our podcast. This episode is brought to you by our dear friends and colleagues over at Risinger Homes. They're an Austin-based, full-service luxury home builder and remodeler, and we've worked with them on many occasions. And Risinger Homes really is a different kind of firm. First, they're focused on building science, which we think is incredibly important, and I encourage you to check out the YouTube channel of their owner, Matt Risinger. It's at youtube.com/user/Matt Risinger. Be sure to subscribe. And secondly, we've seen time and time again how much architects really appreciate the seamless experience of working with a builder who has an in-house architect/builder. Risinger Homes has exactly that person. His name's Eric Rouser. So architects, call Risinger Homes early in the design phase of your projects so we can team up with you and your client to build a great home.
Welcome to the Building Science Podcast.
Bringing the human factor to construction, design, and architecture. Brought to you by Positive Energy in Austin, Texas.
Okay, hello and welcome back, everybody. I'm Kristof Irwin, your host of the Building Science Podcast. Today we're continuing our IEQ series, that's Indoor Environmental Quality, and today's episode is on thermal comfort. I am thrilled to be introducing to you our guest for today, Mr. Robert Bean. Robert is the principal and founder at Indoor Climate Consultants, Inc. He hails out of Calgary, Canada, and there he is a professional licensee in mechanical engineering. That's a PLEng. He's also a registered engineering technologist in building construction, and as you will soon see, he is an articulate man and an outstanding educator as well as an outstanding engineer. I can attest firsthand to his ability to teach. I took a heat spring course on integrated HVAC engineering a couple years ago, and it was just awesome. Robert, speaking of educator, he's on the ASHRAE Learning Center faculty. He also serves as a force for good on other ASHRAE committees, I would say chief of which is SSPC, which is Standing Standard Project Committee 55, and that is the standard on thermal environmental conditions for human occupancy, hence his invitation to speak to us today on thermal comfort. He's also, as part of SSPC 55 duties, he is the liaison at Standard 62.2, which is, of course, the famous ventilation standard. Again, human factor building design is present. In fact, Robert is the originator of the phrase, so far as I know, and it's one of the most important phrases I think we can all remember. And it is designed for people, a good building will follow. So let's see, what else? ASHRAE, he is also on Technical Committee 6.1, which is their hydronic systems committee. He's on TC 7.04, which is exergy analysis for sustainable buildings. Huge, important topic, and we will touch on it today. He's also on ASHRAE, their residential buildings committee. And last but not least, Robert is a true gentleman of our industry, and I'm deeply grateful and honored to call him a colleague and a friend. So Robert, if you were given the chance to introduce yourself, how would you do that?
Okay. Well, I'm Robert Bean, and I have spent the last 30 some odd years, in the trades and in doing engineering work, but my last 10, 12 years has just been really focused on indoor environmental quality and people. And it's just sort of discovering that indoor environmental quality is sort of it's like the hub of a wheel, and it's at the crossroads of all these different studies, and it's just it's been a great place to find myself at that crossroads, putting together all of the pieces of the puzzles that I've sort of been working on for the last 30, 40 years, and that's who I am, Kristof. I'm just this guy that's just studying this stuff, and
Just loves this
it's
stuff.
been a lot of fun. Yeah, I came across this great quote, and I have it on my Twitter feed now, from Beethoven. And I'm going to paraphrase it because it's to make it more general, gender equivalent. But Beethoven said, "Don't only practice your art, but force your way into its secrets, for it and knowledge can raise humanity to the divine." Isn't that great?
Beautiful, yeah.
Well, I'm forcing my way into the secrets. Whether I get to the level of divinity, I don't know, but I'm going to pry open everything I can and find out the secrets of this whole world of people and buildings and architecture and physiology and psychology. That's what I'm going to do.
Awesome. So we're going to try to, that's awesome, and we're going to go there. So just for you guys listening, Robert and I are going to be trying to constrain ourselves mainly to be talking about thermal comfort today. But as you can hear, the thermal comfort is one aspect of a much larger topic, and it's IEQ. And in fact, you've heard me say on this podcast that if you design around people, a good building will follow. Well, now you're going to get to meet the guy who came up with that quote. That's Robert. And I also want to do a quick introduction here, a little bit of housekeeping. We are speaking to Robert through the magic of Skype. He is in Calgary, and I can attest to you that he is not a Cylon. He is fully human, and if you hear little clicks and beeps, that's just the internet connection. So without further ado, we're going to introduce the topic here, and I'll take it from here for a few minutes or a few sentences. So we're talking about thermal comfort, but that's general. We're talking actually specifically about thermal comfort for people, for human beings. Most of us are mammals, and we're talking about human beings inside homes, right? We're not talking about thermal comfort outside. That's a different matter. We're talking about inside buildings and inside homes. And so I'm going to start with defining homes and buildings, and then we'll let Robert talk about thermal comfort. So a building, right? So we know what it is. Functionally speaking, from the perspective of thermal comfort, a building is an environmental separator, and it is separating the indoor environment from the outdoor environment, and it is making it such that we can have a shot at controlling the conditions in that indoor environment so that we can make it comfortable in a way that people will say, yes, I am comfortable. And thermal comfort is one of those simple sentences or simple phrases. Thermal comfort seems like something you could say, oh, that's obvious what it is. Very much like saying, oh, this is delicious. Seems obvious that delicious. But if you try to define what delicious is, or you try to define what thermal comfort is, it's not so easy. So how would you define it, Robert?
I'm gonna join the sort of the global community of thermal comfort scientists and use the sort of the universal definition. And this is kind of, and your point is really valid. Like, we should be able to roll off the definition of thermal comfort like it's an old Frank Sinatra classic. So now I just dated myself, right? So, but what the worldwide community of people that study this topic say is that thermal comfort is a condition of mind. And there's some other stuff that goes along with it, but it's a condition of mind, and which means that thermal comfort actually resides inside your head. And because it's your head and not your friend's head, it's a subjective feeling. It's something that we sense the environment with the receptors that we're given. It's a gift, right? These thermal receptors that we have. And that sensation travels, into our brain, where it's interpreted at both a conscious level and a below conscious level. And what's cool about that is that, neuroscientists have, we map the brain, right? Like we know now that the brain lights up when people are talking and when they're feeling pain. Well, they also now know that when people are uncomfortable or comfortable, the brain lights up in different areas. And so really it's a condition of mind. It's in your head.
That's wild. And so you can understand why it's an important topic, because it's also something that people expect guys like us to deliver to them. Could you deliver a state of mind to me, please?
Yeah, and so what's really interesting about that, and we've been talking about this for a long time now. I mean, we got to know each other just through the world of education, and we've had fabulous discussions. And one of those discussions is just how an industry that has based its entire services and products on comfort really don't know what it is. And they think that you can throw a thermostat up on the wall and control it to 68 degrees because that's what the code says, and so if you can do that, you're going to meet the definition of a comfort, and that's just so lame. It's just, it just really doesn't give the respect that the human body has for being this beautiful sensor and being able to take that information in and process it at a neurological and chemical level that the body does. Yeah.
Okay, so let's go with that. Let's go with the human body. So what we want to do is we want to achieve in our clients a state of mind that's expressing satisfaction with the surrounding environment. And so the satisfaction is in their bodies. How does the body itself regulate temperature, or how does it like to regulate temperature? And can you talk about that a little bit, please?
So it does it in a really elegant way through hormones and the nervous system. So if we actually start from the outside and work inwards, you have thermal receptors in your skin, and you literally have thousands and thousands of them. At one time, I think Dr. Marsh estimated that there was something like 160,000 thermal receptors in your skin, and those aren't, they're not distributed in equal amounts around your body. You actually have more sensors in your exposed area, so your head, your hands, your feet. And those receptors, they're not like a thermostat. They're more like a transmitter. They transmit a signal based on changes in temperature that's in the skin through your nervous system up into a part of your brain. Two parts, actually, the thalamus and the hypothalamus. And the thalamus is kind of like, the air traffic controller for your head. And it just says, okay, we've got this information coming in, and we need to direct it. So it directs some of that information to your conscious part of your brain where you have that thought, hey, I'm hot or I'm cold. But at a below conscious level, it's sending that nervous signal to also the hypothalamus, and the hypothalamus is connected to the pituitary gland, which is connected to the thyroid gland. And so what happens is it's getting this signal back from the outside world based on the firing rate of your receptors, and it's taking that, and it's also measuring two hormones, T3 and T4 hormones, which are produced by the thyroid gland, and it's measuring those concentrations of T3 and T4 hormones, and it's saying, you know what, I was programmed at birth through DNA that when I'm comfortable, when I'm in this place called homeostasis, this is the concentration of these two hormones, and this is sort of the firing rate. And when those things aren't according to the program in the brain says, okay, well, we need to do something. And so if we're cold, what happens is the hypothalamus sends a chemical handshake to the pituitary gland with a hormone, and the pituitary gland takes that information and says, hey, I got to send a message to the thyroid gland, so it sends another hormone, another chemical handshake to the thyroid, and the thyroid says, hey, I need to produce some fuel. I need to get the body's metabolic rate up. So it produces this T3 and T4 hormones, and that sort of travels through your whole body system looking for receptor cells that are related to metabolic rate. So things like muscles and respiration and digestion, so that your body starts to warm up. And when your body starts to warm up, then the levels of T3 and T4 come back, and they're now sort of back to where you're in a happy place, and that's what happens.
I like it. So when it's let's say it needs the body to warm up, is that where goosebumps would come from, or shivering? It's muscle contraction there?
Yeah, so when you get into those the sort of extreme, right? So when you start to get goosebumps and you start to sweat, like your body has gone, past sort of that middle ground, and we're going to talk about PMV and PPD, sort of that, right? And so as you get further and further away from being in that happy place, then you're going to start to shiver, and you're going to get muscle contractions, and you're going to start to reduce your body surface area, so you're going to huddle, or you might choose to do jumping jacks or do whatever it is that you can to get your comfort level back. So yeah, that's what's going on. It's really cool, right? So
it's a good thing we don't have to do it consciously.
Well, isn't that the beautiful part about the human body? You think about this, right? Like, if for everybody that's listening today, like, think, your body maintains a core temperature that's, constant. It's not, people get fixated on this 98.6 degrees, but the reality is that it can be, 97.5 to, 9 degrees. It varies depending on whether you're sleeping and what you're doing. But, it's within 1 or 2 degrees that the body maintains a constant temperature. But outside, right, like where I'm from in Calgary, we can go from minus 40 degrees Fahrenheit to, 85, 90 degrees Fahrenheit. So even though the outside world has these huge swings, inside of us, we have this very narrow band that we have to maintain in order to stay healthy. So it's really cool how the body and maintains that constant temperature.
And is homeostasis as simple as that you maintain? Is that the same as saying homeostasis? You maintain this core body temperature, or there's a lot more to homeostasis?
Yeah, homeostasis is sort of a general term that says, when everything is inside is at a fairly low stress level, that you're in a happy place. And as you move away from being in that homeostatic state, so you're overheating or you're underheating, then the body starts to respond. And if it can't solve that problem, because we've lost all other solutions to the problem, then the stress level goes up, and then you're no longer in a homeostatic state. And that's actually one of the cool areas of study right now is looking at homeostasis, and then this other term, allostesia. I think I pronounced that right.
Ah.
Okay, and so that allostesia is really about that's sort of looking at what are the benefits of testing the body, like what happens when we move from being in a happy place to not such a happy place to a really bad place. And it's kind of like this exercise for your sensory system. So for example, like if we take an athlete, right? Mm-hmm. How does an athlete develop balance? Well, they develop by being out of balance and recovering, right? And so the study, the study of the tension between homeostasis, where we're in a happy place, and allostesia, where we're moving in and out, it's just a great field of study right now. Because how far should we test our sensory systems? What's good and what's not good? Like, where's the stress level where it's a bad stress, and where's the stress level where it's actually can be considered exercise for our sensory systems?
I like it. So satisfaction. So that's a long way of saying that the body has all these automatic systems to achieve experiencing satisfaction. And I like the way you said that you can get way out of balance, because us doing mechanical designs, if we've ever made our clients sweat or shiver, we're way out of the bounds. So satisfaction is a much narrower range. Okay.
And where this is really interesting, Kristof, and everybody else that's listening, is that when you look at the demographics in North America, we have this baby boom population that's starting to mature, and of course our generation before that baby boom generation that are now starting to pass away. But we have this really large population that's aging, and the body, and this is one of my current areas of study, is that how does the aging body respond to these environmental stimulants? When you get really cold and you get really hot, and how does climate change or changes of consequence, let's put it that way, affect those elderly population or infants, the sort of the vulnerable population. So when you think about infants, those that are infirm, all of those, that the building can't change, right? It's a fixed thing. But the mechanical systems, we're typically not going to be changing them. So, but the body is changing and the outdoor conditions are changing, and so in between the body and the outdoors is this enclosure, and if that can't change, then something has to happen. And what happens is the elderly person or the infant or the injured, they get more stressed than, say, a younger person who might be in a really good, healthy state. So that's why building enclosures are so important, and why we need to first get our buildings fixed, and so
Absolutely.
we design, And we use the body, right? I mean, this statement about, if you design for people, good buildings will follow, and that's what that's all about. Is that, if you design the enclosure to satisfy the person, you end up with really good buildings, and buildings that can deal with climate changes and deal with aging and all of these things that come together.
Yeah, and the synergies are there too. It's not just that we do it for health and comfort, but the energy efficiency will come along as a synergy, and durability as well. So let's talk about that. Let's talk about buildings, because we're talking about the basic definition of thermal comfort being expressing satisfaction with the surrounding environment. And the surrounding environment is the building and the thermal conditions in it, or the psychrometric conditions in it, to expand it. So you and I have talked a lot about this thermal flux density as being one of the factors of the building we'd like to see. For our audience, could you define that briefly, thermal flux density?
Yeah, thermal flux density. So, for the lay person, what we're talking about is how many matches need to burn per square foot. Yeah, so what you want to do is, so you guys, when you're doing, Matt comes to you and he says, Kristof, we got this project and we want you to do load calculations. So your guys and girls in your office, and you have smart girls and guys in your office, right? They just take these drawings and then they start to crunch the numbers and they do their magic. And you end up with this number, like how many BTUs per hour per square foot. And we're really talking about how many matches have to be burning on a square foot of floor area in order to compensate for the losses of the building. And so when you have a bad building, you're going to have a lot of matches in that square foot. And when you have a good building, you're going to have less matches. And so we define buildings really sort of in 4 categories. Those that have less than 10 BTUs per hour per square foot, or less than 10 matches per hour per square foot. And then between 10 and 20, and then 20 and 30, and then 30 to 40 and beyond. And so if you look at, sort of the tradition or the terrible building, like buildings way back when they used, newspaper or no insulation in their wall cavities, single pane glass, the buildings, leaked. Those were a terrible building. They, and we're not saying that the trade quality was terrible. We're just saying the thermal performance was terrible, because back then, they used real wood and real materials, and the trades guys were actually tradespeople. They were very skilled in what they did. So we're not talking about the quality of the workmanship or the materials. We're talking about how the building performed. And then you go from the terrible building to sort of the more traditional buildings that were sort of built in the 60s and the 70s and the 80s. And then we moved to the transitional building, which is, buildings that are now sort of in that 10 to 20 range, the double, triple pane glass, not quite passive house standard, just maybe 3, 4 air change, 50 type of stuff. And then you get into the terrific buildings. And I define the terrific buildings as anything that's less than 10 BTUs per hour per square foot. And so that's when you start to talk about, passive house, and in Canada up here, the R2000 program and Equilibrium and all of these other great houses. And when you get into these really low loads, that's when you start appreciating the role of the enclosure, because it regulates the loss of the heat from the body. I mean, that's your interface right there. And so a bad building, 40 BTUs per hour per square foot, really just sort of extracts the heat from the body at a rate faster than what it can generate internally. And so that makes you uncomfortable. But these high performance buildings, they allow you to retain your body heat. And so you can maintain this homeostasis without having to use mechanical or thermal or electrical power, for longer periods of time. And so that's what it's all about.
Yeah. We could do a whole side discussion just on how important the buildings are. And so one more feature that I think our listeners will know, actually, to wrap up thermal flux density, anyone listening is probably getting a load calculation, which is a peak load calculation. And you can calculate your thermal flux density. Don't let those words intimidate you. It kind of reminds me of, what's that, Bugs Bunny, the Illudium Q38 space modulator. That being has stolen it. Yeah, but so the thermal flux density, like let's say you get a manual J for a residential project, and you find out that your peak load is 48,000 BTUs an hour, which would be 4 tons in cooling mode, and you divide by your square footage. So if it was a 4,000 square foot house and divide 48 by 4,000, you're going to end up with something like 12. I think that's the right math. So that would be right there, right on the between transitional and terrific.
Yeah.
And so it's a very straightforward calculation that I encourage all you guys listening to be doing it and seeing where you are and keeping track of it. And implicit in a good building is also the fact that the air can't leak in from inside to out. Thermal flux is measuring energy flow, so it's measuring heat in all its forms. One of those forms is convective heat transfer. So that means we need an airtight building. Robert, where do you like to see air changes per hour? You know, the codes, by the way, down here are 5 air changes per hour or less. I assume you want less than 5. Where do you suggest that number be?
If you can get into the sort of the 3 range, 2 to 3 range, that's a nice place to be.
Yeah.
If you want to be really, aggressive, and I mean aggressive in a good way, and you want to start to get down to the passive house standard, 0.6, that's pretty commendable if you can do that. 1.5 is also really good. So if you're down in that 1.5 to 0.6 range, you're doing some really phenomenal construction techniques, which is great. And
yeah,
so it's
great.
Yeah. But if you can get to 3 to 2, you're doing pretty good. And a lot of it also depends, where you're building. Like if you're building, where I'm from, or north of where I'm from, we get down to -40, -50 degrees Fahrenheit, and all of a sudden,
unbelievable.
Yeah, that's really cold, right? And so
that's 120 degrees delta T, 120 or more than 100 degree delta T inside out. That's whoa.
Yeah. So the enclosure becomes really important, but this is not magic, right? We know how to do this stuff. We've been able to do this stuff for, I got out of school in 1983, and back then in Canada we had the R2000 program, and that was all about tightening up the building. And so people today, if you're getting a code built house, where your air changes are like 5 ACH 50 or 8 ACH 50, like, come on, like that's just so terrible. That's in the terrible traditional category. We're so far beyond that, and
it is kind of shocking that we as a society don't ask for more with our buildings. But that's another discussion. So a tiny bit more about buildings. I can think of 2 things. One is almost ahead of what we just said because it influences this. But this is the architectural design. It's the big ones. It's the massing, the orientation, and the aperture. How many holes in our enclosure. So windows and shading, that's a very important topic. I think we should just move past it because I want to ask you another one. Interior finishes is something that you've talked to me about, and I think I'd like to just touch on it somewhat briefly, Robert, but because we have more to go to get it back into thermal comfort. But there are aspects of interior finishes that impact thermal comfort. I'm thinking of things like, can you think of some?
Yeah, so the interior, if I could have, an interior designer on every design team,
man.
The world would be so much better. And because interior finishes, we have an intimate relationship with these finishes through our sensory systems. And so just to give you an example, when you look at floor coverings, the barefoot on a carpeted floor, and the barefoot on a tile floor, and the barefoot on a hardwood floor, they could all be at the same temperature, but because of their connectivity, you have a different experience with them. And so this is really cool, and people can do this online. Like if you want to do something with your kids, is that just take a piece of steel and a piece of wood and put them in the fridge overnight. Like do this with your kids. Just take these 2 materials, put them in the freezer overnight, and then in the morning come back and just hand them to your child and say which one feels colder. And they're going to always tell you that the steel feels colder than the wood, but the reality is they're at the same temperature. And you can, and the kids are going to go, well, that's really cool because this one actually feels colder, but in fact they've been in the freezer all night. They're the same temperature. And what's happened is the steel is very good at extracting energy out of your hand, as opposed to the wood. And so these floor coverings, they have an impact on that. Floor coverings also have an impact in VOC emissions. So, for example, we were mentioning windows and window performance, right? So, shortwave energy, which is the energy from the sun, high intensity, it travels through the glazing systems depending on their solar heat gain coefficient, and that energy hits the flooring materials. Well, some flooring materials are more susceptible to breaking down in the presence of shortwave energy. And so if you use more natural materials like tile, slate, terrazzo, stone, even wood products without finishes on it, they don't break down in the same way that, say, some synthetic materials do, right? And when you start looking at anything that man has their hand in terms of putting stuff together that has to use glues, for example, those glues become the recipient of shortwave energy, and as that temperature rises, they start to lose their structure and they start to outgas. And of course, that outgassing in the form of, say, formaldehydes, becomes a lung irritant. And so the interior designers, they get materials and they get things like color and texture and composition. And so if you want a really good indoor environment, they understand natural materials, they understand these types of things. So
yeah, beautiful.
Yeah.
So we're teetering on the edge of transitioning out of thermal comfort into indoor air quality, because you mentioned earlier hormones are these chemical messengers that regulate thermal comfort. Well, things like these glues that are outgassing into the space, or mold mycotoxins, microbial VOCs of many different types, our body erroneously interprets many of those compounds as hormones. I mean, you know that. And so it's this interesting mix where we say, let's put this magic material in that's, cheaper than wood because it's made of compressed trash and glue or something. And and yet we think with our wallets when it comes to the built environment instead of with our heads and hearts and bodies, pretty much. I think, go ahead. If you want to say something, go. Otherwise, we can move on.
If there's any message that we could leave your audience is that, there is illiteracy in the world of architecture, and that illiteracy starts often with the client, and it's putting your faith in people that don't know what they're doing. But what we're talking about here is we're talking about your health, your own personal health and the health of your family. We're talking about your cash flow. So when we talk about mechanical equipment and operating mechanical equipment, every month you're going to get a bill from the utility company. And so we're talking about your cash flow. We're talking about protecting heirlooms. So maybe you receive, maybe you have a piano or musical instruments or paintings or furniture. These are really important things, your health, your finances, and your assets. And so when people go out and they start to hire builders and mechanical designers and tradespeople, they forget about these three critical components. And that's part of the illiteracy that exists. And so what they ought to do is just sit down with their family and say, well, what does this house mean to us? Like, this is our refuge, this is our privacy, this is our our place where we raise our families. So it has to be an environment that promotes health, and it has to be an environment that's not going to penalize us because it's going to cost us so much to maintain these environments. And it has to be an environment that allows us to enjoy the things that our forefathers have handed down to us, these heirlooms and assets. So it's we need to have educated buyers, and when you have educated buyers, they put pressure on industry to smarten up, to pay attention to these things. You guys do it. Kristof, your company, and and Matt Reisinger. I mean, I can't think of a better partnership in the industry. In Austin, Texas. I mean, there's partnerships like that in other parts of the world, but in your neck of the woods, I mean, Matt gets it, and you guys get it, and when you bring together those understandings, boy, the clients are so lucky to have you. So,
Yeah.
how was that for a plug for you guys? Was that okay?
Yeah, independent of that plug, I think you guys listening can see why I love this guy. But just to go a little bit more on this, because it's very important, one of the things that is also a slight distortion of my market is that I work for homeowners. I do single-family homes, typically custom single-family homes. And the beauty there is that it is a family, and they can make good decisions, because multifamily building, many commercial buildings, the owner is a developer who's not going to live there. He's not going to own it for very long, he or she. And so there's misaligned incentives there, right? We treat the built space in our society as an ATM, and there's the costs, we don't appreciate true costs. The healthcare costs, the cost of if I'm grumpy because my sinuses are all messed up, and then I piss off my wife, and then I go, got to go through a divorce, right? There's like all these costs that could happen.
Yeah, I know. And that's you get the the thermostat wars, right? And that's the fighting that goes over the thermostat. Well, that's like you need marriage counseling just to operate your house, and part of that is because you have a bad building, and part of it is that there was no budget for proper controls and this type of stuff. But what's interesting, like for example, if you use the metaphor, the analogy of, a parachute, right? Like we have people building parachutes that never jump out of planes. So in other words, we have people building buildings that never have to live in the house. So there's no incentive. Like they don't, they want to build it, they want to collect the check, and then they want to move on to the next project. And the people that are inside the house, they're jumping, like they're committed. We're in this, right? We paid you to build this house, and we have to live in it. And we have to, at some point, we have to also sell that house to the next buyer. So we've bought the parachute and we've jumped, but the community of buildings, they're building a lot of parachutes, but none of them know how to jump out of a plane. Like they just don't have to use the very thing that we're relying on. And that's wrong. That's good.
It is. It's wrong. And you guys listening, we've gone across this terrain before, and it's worth going over and over, because you need to feel it in your bones that what we're doing is wrong. But back to where we were. So we were discussing enclosures. The last topic was interior finishes, right? And this means that we want a smart interior designer on every project, one that's going to be able to talk about absorptivity, emissivity, conductivity of these materials, their outgassing VOCs, what's in them. We need this on every project. It should not be considered a luxury. And why it's not a luxury is because your body, your parents, your kids, your beloved pets,
yes.
They are all having an intimate relationship with interior finishes, whether you know it or not. So, let's talk about classic thermal comfort in some sense, right? We're talking about creating a surrounding environment that's going to promote a sense of satisfaction or a mental experience of satisfaction. So there are, fortunately for you guys listening that are more quantitative and want just, to know the rules or know the components, there are standards associated with thermal comfort inside buildings. And ASHRAE is an international standards organization, and they have their standard 55, which has been most recently updated in 2013. And then there's an international standard, do you remember the number on that, Robert? I'm sure you do.
ISO? 7730.
Okay. And are they lining up, by the way? I've never thought to ask that to you. It's 55 and 7730.
Yeah, so the DNA...
Are they radically different?
No, they're not radically different. The DNA, the soul of those standards are very similar. The European standard has, probably what differentiates it from the ASHRAE standard is a classification. They have 3 classes. So you can have, a good environment, you can have, a great environment, or you can have like the awesome environment. So, if you're looking
is that the European terminology?
No, they call it a class A, B, and C. But awesome environment is the class A, and that's where more restrictive, like less fluctuations that are tolerated in the space, and a class B and a class C sort of lowers it down. So it's a nice way of doing it, and our committee at ASHRAE in North America, what we call SSPC 55, which is responsible for the standard, we've considered the class system in the past, and we'll consider it again in the future, and you never know. We might find it in the future versions of the standard.
Yeah.
Yeah.
Okay, so I want to get into the thermal comfort factors, but I also want to remind people that, especially you guys working on project teams, and if there's any homeowners or people that we're about to develop, create their own project for delivering thermal comfort to themselves and their families, that these standards you need to remember that these are international standards that deal primarily with large bodies of people, right? So they're statistically based, and they're saying, like, in general, if I create these conditions, most of the people in this space are going to be comfortable. But there's implicit subjectivity in thermal comfort, right? It's a state of mind. And so we need to remember that these standards are starting points, but that they can be customized for different people. And I really love, Robert, what you were talking about the aging and the infants, particularly the aging populations. That standard 55, I could imagine an addendum one day that talks about that. Like, if you go beyond a certain age, which how would you, maybe not age, metabolic rate or internal functioning. Anyway, I'm thinking out loud.
Yeah, I mean,
you get where I'm going.
Yeah,
it's just a.
Yeah, I do. I mean, the standards now, they really sort of target the healthy young person. Well, not necessarily young, but just a healthy adult, and they don't
there you go.
address the the other sort of the more vulnerable populations. That's not to say there's no body of knowledge in that. There is. It's just that we haven't been able to synthesize it into a document or as an addendum to the existing ones. But I think I agree with you, Kristof, that at some point in the future that we'll see these documents include these other populations, and I this is important stuff. And the standards, they allow you that flexibility. So yeah, okay, they're written for a certain population, but that doesn't mean that we ignore the elderly or the infants. We recognize that they have more important needs, I would say, than the average person, and that we can apply the standards to them. Yeah.
Yeah, even the ergonomics of the control systems. Go ahead.
Yeah, that's a great topic. We could talking about being the hub and all of the spokes coming into control. Ergonomics is one of them, right? I mean, when you get older, you lose your your visual acuity, your manual dexterity, your cognitive abilities, and so the last thing that we want to do in these spaces is have really sophisticated, complicated controls. We want things that large dials, backlit, very simple, and even myself. I mean, I as a technician, I've been up the technology ladder and down, and I laugh when I hear people talk about the Internet of Things. Like the Internet of Things is going to solve these problems, and that's just not the case at all. I mean, when we have wired devices, but those devices are so complex and the people can't use them. Well, it doesn't matter how zippy they are; they're still just trash in my book.
I could imagine you wear something that's monitoring your state of comfort or your metabolic rate, and it's just automatically communicating with your control system.
Just because we can do stuff like when we see people doing that, where because the technology is available, they gravitate to it like fish going after a shiny lure, and they basically toss aside all the things that you and I have been talking about, like let's first get the building fixed, right? Like, and that's first, and then focus on interior finishes and appreciate the intimate relationship that people have with the finishes and the enclosure. We do all of that before we start talking about the Internet of Things, right?
Yeah, absolutely.
We need to come back to reality.
But we as a culture, we love product-based solutions because someone can profit on selling you that product to solve your problem. Whereas with the buildings, it's a process, and we're kind of confounded about how to profitably shift our process.
Yeah, so in the ASHRAE standard, like there's 10 metrics, right? Well, none of them none of the metrics in the standard relate to profit.
Yeah,
right.
There you go. So let's talk about this. Let's talk about the 10 thermal. Sorry, if you want to finish that thought, go for it.
Yeah, no, let's talk about those 10 things, because they really, that's the body of knowledge that has sort of evolved. Is based on these sort of 10 factors that sit inside the standard, and profit isn't one of them. But there's.
Okay, everybody. I'm a little bit reluctant to do this, but we do need to split this episode some point because this conversation has a lot more to go. So what we're going to do is start the cliffhanger right here. Da-da. And we're going to get into the 10 quantitative metrics associated with thermal comfort for putting humans inside spaces next time. I look forward to being with you then.
This episode is brought to you by our dear friends and colleagues over at Risinger Homes. They're an Austin-based, full-service luxury home builder and remodeler, and we've worked with them on many occasions. And Risinger Homes really is a different kind of firm. First, they're focused on building science, which we think is incredibly important. And I encourage you to check out the YouTube channel of their owner, Matt Risinger. It's at youtube.com/user/Matt Risinger. Be sure to subscribe. And secondly, we've seen time and time again how much architects really appreciate the seamless experience of working with a builder who has an in-house architect/builder. Risinger Homes has exactly that person. His name's Eric Rouser. So architects, call Risinger Homes early in the design phase of your projects so we can team up with you and your client to build a great home.